Hi everyone, today I will present a short paper called DigitalTraces, Unveiling Fraud Through Interactive User Behavior Exploration. I'm João Bernardo and this paper was originally presented at Eurovis 2025 Short Papers. So first of all, a bit of context. So every time that you make a transaction or that you interact with your bank or financial institution, being it through your phone, your computer, or even your smartwatch, that transaction might go through a fraud detection system. That fraud detection system, like the one that we developed at FIDSI, that is based in rules and in machine learning models, it categorizes the transactions in one of three possible categories. The first category is not fraud, meaning that there is nothing suspicious about the transaction. The second category is fraud, meaning that the transaction is fraudulent and is then blocked. Or under review. When the model is not sure if the transaction is fraudulent or not, but it believes that there's something suspicious about it, it can go through a real human analyst that makes the final decision. In this case, human analysts look into a number of different data regarding the transaction to make their final decision. So that information can either be previous transactions of that client, can be the card type involved in transaction, the fraud history of that client, the location of the client and where the transaction was made. It can also be merchant information, other client information. When we refer to client information, we could be referring to a lot of different kinds of data. In this case, in this paper, we are concerned with a specific subset of data that is usually considered by analysts the most important. And that includes login activity, basically when and how often does a user interact with their home banking system. Account changes, so basically every time that the client does some change that concerns, for example, the email associated with the account, the phone number, the password, or even the address. Device usage, basically with what devices and how often does the user uses them to actually interact with the system. And finally, the information on when and what new devices are introduced is also really important for analysts. And we call this set of data digital activity. With this data, analysts are able to establish some kind of footprint of the behavior of the user. When the behavior changes from previously established patterns, that's something that tells the analyst that the behavior is suspicious and it could very well indicate fraud. Having explained the context, I will now explain the problem that we want to solve with this paper. First of all, analysts have to actually manually cross-reference multiple data sources when they do their analysis, as these different kinds of digital activity data are available in a number of different ways and are presented in a number of different ways. Second of all, there's no integration right now with fraud data. So when analysts want to perform a correlation analysis, they have to check, again, multiple different sources. There's also no historical view in a way that presents all of this data at the same time for a specific time period, limiting analysis. And finally, analysts have a limited time for analysis. Usually, they have an average of 3 minutes to make a decision on a specific under review transaction. Based on a number of interviews with analysts and based on our problem definition, we came up with a list of requirements that the visualization that we want to develop would have to answer to. So first of all, it should provide an overview of device information and account changes. It should facilitate the identification of new devices. It should help on the detection of changes in user behavior. It should integrate fraud data history to support correlation analysis. It should support different time windows. It should facilitate the analysis across multiple dimensions at the same time. And it should allow for further analysis by being integrated with FeedSeye's fraud detection software. So before starting the design of our tool, we looked into literature to find some examples and inspiration. So here you can see some examples of that related work. They are all more or less related. We were looking into stacked heat maps and ways to visualize multiple data dimensions at the same time. So the first two on the top are more related with the fraud detection topic, and the two on the bottom are more general. So introducing our visualization, we call it DigitalTraces. I'll go in detail through each component, but here you can already see an overview of the visualization. So you can see that on the x-axis there's time, and then you have different stacked timelines for each dimension of data. You can also see that data is segmented in these rectangles. We call them time blocks. So here you are seeing a visualization of the last 3 months, so each block refers to a single day. So first we have here the header, and you can see there a legend with the encoding, the color and symbol encoding for the different parts of the visualization. You can also see a legend for the heat map colors, and you can see a time picker that is now selecting the last 3 months. Then we have a bar chart for fraud. You can see the maximum fraud value on the left and on the dashed line, and then for each time block you can see the total fraud. So you can see here that there are only 3 days with fraud associated with this client. Then you can see device information. So first of all, you have a device summary timeline. In this timeline, you can see the number of logins per day or per time block during the selected time period. And the frequency of logins is color-coded. So the darker, the more logins happen during that time period. Then you can see small circles. They indicate when a new device was introduced. Finally, you can see device timelines. So basically you see the number of logins by device, and the devices are paginated and they are ordered from the most recent one. As I was saying, here you can see the device list working. So you can either scroll or click to go up and down and see all the devices that interacted with this client. You can also click on the new device symbol, and it automatically makes the list jump to when the device was introduced. Then you have the account information part. Here you have an account summary showing all the changes in the account information, and then you can see specific timelines for the most important data regarding account information. So you have email, phone, address, and password. You also have the colors showing when the changes were made. So the blue means that there was a change, and the yellowish tells the user that there was a change to a block list, information. So for example, if the user changes the email to some address that was previously identified by our system as suspicious or as fraudulent, then it could have been blocklisted. And if it's blocklisted, then it will show here with this different color. We use tooltips to communicate extra information to the analyst. So the analyst can hover through any block in the visualization, and there they can see more information about that specific part. So when they hover through a session timeline, they can see the number of sessions, the amount of fraud, what new device was introduced, and when they hover through a device timeline, they can also see the specific number of sessions for that device for that period, and also when the device was first seen and last seen. When they hover through the account information part, they can see what was the old email and new email, and also what was the previous address and new address, or previous phone and new phone number. Finally, to answer the final requirement of allowing further analysis, the user can click on the name of the device, and by doing that, they will copy the ID of that device that then can be used to gather more information about it based on other databases and tools. To validate our approach, we interviewed two different analysts, one with 15 years of experience and another one with 10 years of experience in this domain. We provided them a task with synthetic data, and this data was generated based on a probabilistic model to try to mimic as much as possible a real case of account takeover, a case like the ones that these analysts look into on a daily basis. So there were three suspicious things in this data. The first one was a spike in logins in two specific days. The second one was that spike in logins was introduced because of a new device. The amount of logins that were atypical all came from this same new device. And finally, in the same period, there was a change to a block-listed email. And the analysts that we interviewed were both able to identify very easily these three aspects. When it comes to future work, we really want to, in the future, do a usability study using real-world data, and we also want to develop custom time selectors because the time selectors that we have now are predefined. So this is DigitalTraces. Thank you very much for your attention. If you feel interested, please check our paper using the URL on the screen or the QR code. Thank you.